I hope you've got your calculators warmed up because today we're doing a t-test speed run. Strap yourselves in and get ready. So today we're going to do a one sample t-test by hand and just for fun. I thought it might be kind of cool to try to do it as quickly as possible, and then if you want you can generate a data set and try to race me and see if you can beat my time. So here are the rules. First of all, I've already got my formulas written out so that it's easier for you to follow along with what I'm doing. Second, I don't know what my data set's going to be yet. I'm going to randomly determine that in Excel, but I know it's going to be a sample size of 5. This way I can go ahead and look up my critical value of t and write it down before I get started. If we look here, we know our degrees of freedom is 4, so that we go down 4 and then we go across to the two-tailed test, and that makes our t critical value 2.776. So I'm going to write that in, 2.776. Okay, so that's our number to beat. Now, I'm going to use Excel to generate the random number sequence, and so I'm going to use Excel's random function equals rand between 0 to 10. And let's see, let me drag down so that I have a sample size of 5. Okay, so we got 7, 10, 2, 4, and 5. So that's our sequence. Don't start any timers yet. 7, 10, 2, 4, and 5. And I'm going to use just the calculator that comes with Windows. This is kind of a bold move, I think, on my part, because this is not a very good calculator, I don't think. But let's see, does it have a square root button? It does. Okay, so we should be good. All right, let's give this a try. So on your marks, get set, go. So 7, first I'm going to calculate the average. 7 plus 10 plus 2 plus 4 plus 5 is 28 divided by 5. That's our sample size. We get 5.6. That's our mean. So the mean is 5.6. We know our degrees of freedom is 4. Okay, so the next thing we need to do is we need to calculate our standard deviation. So I'm going to do this in steps. We're going to do x minus x bar, and then we're going to square the result. X minus x bar squared. So this is going to be 7 minus 5.6, 10 minus 5.6, 2 minus 5.6, 4 minus 5.6, and 5 minus 5, that's a 5.6. Let me pull up my calculator, and we can do 7 minus 5.6 equals 1.4. 1.4. 10 minus 5.6 is going to be 4.4. 2 minus 5.6 would be negative 3.6. 4 minus 5.6 would be negative 1.6. And 5 minus 5.6 would be negative 0.6. So now we need to square each of these. That's a 1.6. Okay, let's see. Let's go to our calculator. Oh, we got to do all the squaring. Okay, 1.4 squared, 1.96, 4.4 squared, 19.36. So that was 1.96. What did I say that was? 19.36. What's 3.6 squared? Negative 3.6 squared would be 12.96. And 1.6 or negative 1.6 squared would be 2.56. 2.56, and then 0.6 squared would be 0.36. Okay, so I've done the squaring. Now I need to do the summing. And the sum of all of that is going to be 0.36 plus, I'm going to start again at the top, 1.96 plus 19.36 plus 12.96 plus 2.56 plus 0.3, oh, I don't need the plus 0.36, do I? I already added that one at the beginning. Okay, equals 37.2. 37.2. Okay, so where I'm calculating my standard deviation, I've done my sum of squares. So this is 37.2 divided by n minus 1 is 4, because we have an n of 5. All right. So that means we need to do 37.2 divided by 4. Whoa. Divided by 4 is 9.3. And then we need the square root of 9.3, which is, let's see, 9.3 square root of is 3. What was it? 3.0, we'll round to 3.05. 3.05. 3.05. Okay, so that's our standard deviation, which is a pretty big number. Next up, now that we've got our standard deviation, we can calculate our standard error, which is the standard deviation, 3.05 divided by 3.05 divided by, oh shoot, this we need to do the square root of n. Let's just clear all of that. Square root of n, so we need 5 and take the square root of it, 2.24. So I'm going to round a little bit. So that was 3.05 divided by 2.24. And that's 1.36 equals 1.36. Did I make any mistakes so far? I'm going fast, so I'm not being very careful. Okay, let's see. What am I missing? I've got everything. Oh, I don't have Cohen's d, but that comes at the end. All right, we've got our standard error. So now all we need is to do our x bar minus mu. So that's going to be, our x bar was 5.6 minus, we said we were testing against the value 7, divided by 1.36. Okay, so 5.6 minus 7 would be negative, why is this so hard? Negative numbers. So they would be the same as 0.6 minus 2, which would be 1.4. So negative 1.4 divided by 1.36. Okay, I already know what the result is going to be. That's darn near 1, right? 1.4 divided by, if you round that, it's 1.4. We get a t-value of 1. 1 is not bigger than our critical value of t, so we do not have a statistically significant difference. Okay, now the last thing we have to do is we have to calculate Cohen's d, and then it'll be pencils down. So x bar minus mu, we already know that's going to be minus 1.4, right? Divided by, this time, the standard deviation, which was what? If I can find it, 3.05, and 1.4 divided by 1.4 divided by 3.05 equals 0.46. 0.46. So that would have been medium. Okay, pencils down, time. How did I do? Can you go any faster? Did I make any mistakes? This is a fun way to practice getting good at t-tests. So the challenge is for you to generate your own data set, try it yourself, Post your own time in the comments below. All right, until next time, keep thinking.